Hello, back again, and this time we're going to be looking at the waiting time section of the randomness module. So as per usual, let me share my screen. Here we go. Okay, so this one, we're looking a lot at Twitter, and I'm really hoping that this will be an interesting context that your students can get kind of engaged with. So, of course, we start off with Donald Trump, and we have an example here that looks at sequential tweets. So on May the 1st, 2020, we can see he had quite a few tweets in a row and then a little bit gap. In fact, 200 minutes later, there was another one, as well as a couple more throughout the day. What I find really interesting about this, can't really tell when the poor guy slept. If we change this to something else, so for example, we go for Lady Gaga, we can see this huge gap between these and this one, right? Some bits and pieces that your students might like to talk about is things that are going on in the data. So what happened on the 17th of January 2021? I don't know. Have a look, see what Lady Gaga was tweeting about. All I know is she tweeted quite a few times and then had a bit of a gap and then another one, and then probably went to sleep before tweeting once more. The trouble with this, of course, is I haven't taken into account where they were in the world. In fact, it's quite difficult to be able to do that because it depends on where they were when they were tweeting. And of course, if you've got someone like Donald Trump or like Lady Gaga, they might not be where they usually live. So their location timing, I suppose, to make it so that they're all on the same time frame, not very easy to do. So we might be able to see some of these different examples. But of course, if we go for someone else like Obama back in 2016, probably slept in this gap here. Let's see, I thought that was a different one. There's a few different examples that we could look at. How often might they tweet? And we can then go on, and if you were wanting to explore waiting times in particular, there's this pretty neat little tool called Scampy. So this is actually what my honours dissertation came from. And there's a few neat bits and pieces in here. So we have enter the data mode, video mode, where you can upload a video. We have simulation mode, where we can specify something in particular, and game mode as well, where you can tap and record times. We are working with data mode today, so I'm actually going to need to make this smaller and head back to here. So let's say I'm interested in the waiting times that The Rock produced. I'm going to copy those and chuck this into Scampy. And what we get is a nice timeline here. We'll change this to minutes. And we've got, these are the times that The Rock tweeted. So 0 being the first tweet that we record from, 5 minutes later, 74 minutes later, since that first tweet. So this is cumulative data. It's the kind of data we need to be able to work this tool. We hit next. We can watch the distribution of waiting times accumulate. So these little bars, they measure the time between one tweet and another before plotting this on the distribution below, like so. And as we can see, there's a bunch around 0. There's one that's really long. It's probably when he was asleep. And then we've got a few in between. We can speed this up. There are sounds to it as well, which I've muted this time, just because I'm talking over the top. Now, if we hit fit, this fits an exponential distribution to it, but because we don't have very much data, it doesn't work very well. It works a lot better when you've got more, which I think I do show you an example later on with that. But otherwise, go ahead, find other data. It doesn't have to be the data that I have on the randomness module. Chuck in any weighting data you like. Particularly video mode could be really cool. Find a video where we're looking at basketball shots, where we're looking at every time the football gets kicked, anything, a 5-minute video where students can click every time an event happens and they can record their own data. This is just an example of how we might use the Twitter data available on the randomness module. So the next bit, we're going to take those exponential waiting times, although they're not necessarily exponential, the waiting times, and we're going to transform those into count data, which, if it is exponential, should end up being Poisson data. We can specify a time interval. Because I'm looking at minutes, 60 minutes kind of makes sense, right? We're looking at every hour. How many tweets each hour? We have our timeline here. We can then watch it build into a distribution of counts. You might need to speed this up a little. Yeah, that's better. We're going to have a bunch of zeros, of course, for when the rock is sleeping. We could probably work out how long he perhaps slept for, assuming that he sent a tweet immediately before going to bed and immediately when waking up, which of course isn't very likely. Should be the last one here. And we have our distribution of counts. Now we can add the fit to it. As I mentioned, this is going to be the Poisson fit, and we can see it doesn't quite work. What this could do with is a little bit of variation so that we can see how things go. There's another tool coming up later that you might like to use for that. For this one, we can see it doesn't really fit. Not really Poisson data. But we can still have a look, compare the two. So we have on the left-hand side, the distribution of waiting times, and we're looking at a mean waiting time of about 90 minutes. So how long would I have to wait to see a tweet from The Rock? On average, 90 minutes. The mean number of events per interval, every 60 minutes, he posts about 0.7 tweets. Yes, so this is a brief introduction to Scampy. Of course, have a play around, look at video mode, game mode, simulation mode, and yeah, data mode is the one I would recommend for this module, however. That's the screen again. Discussion time, not all tweets will be random. Some celebrities or companies have timed released updates. So in particular, something that people noticed when analyzing the Trump data is that there were very much two different kinds of tweets that would be posted to the Donald Trump Twitter site. So there were the ones that were typically quite negative, we will admit, and at really random times of the day. And then the ones that were quite a bit more factual, they were very much more statements, and they were posted at very regular times of the day. So there's a bit of a theory that maybe there's two different tweeters to the Donald Trump page before he got banned from Twitter, of course. So yes, some of the Donald Trump tweets might be the 9 a.m. How are you today tweet that is from the administration rather than Donald Trump himself. But of course, it can be a little bit hard to pull those out. the people that I've gone for, the celebs that I have in the list. Hopefully your students will be able to find one that they kind of connect with. And hopefully they post fairly random. Of course, the background of this is still random, right? The Rock might post a tweet every hour and a half on average, but that is of course not what we saw in the data in terms of how long we might have to wait. If he posts a tweet, he might post one only 5 minutes later, only 10 minutes later, not necessarily an hour and a half every single time. And there are things like dinner time, lunchtime, bedtime, being on set if they're an actor, being in a conference if they're someone more like Barack Obama or Donald Trump. And of course, there are different things in our lives that affect when we have the time to tweet. It is kind of random, right? And again, I haven't got some examples up yet, but I should have some examples of the kinds of discussions that your students could have. So if this is a take-home exercise and they have a go discussing this with their whānau, they might like to have a look at some examples of how this discussion might go down, especially without the guidance from yourself or their peers. Okay, so the next step is starting to build this into a more defined distribution. So in May 2020, @the real Donald Trump tweeted almost 550 times. And although I don't have the video up there yet, there will be the opportunity to listen to this phone buzz 13 times on the 1st of May. So we get a sense of the randomness of it through a different medium. Headphones recommended, otherwise you will go insane with 13 tweets from each of your students or groups. Okay, so we're interested in the time between tweets, which was shown in the video as the lines. We'll also have it replicating what we see in the Scampy tool. Word. So if we plot the time between each tweet, we start off with a sample size of 13. This is what we got on the 1st of May, and then we can increase the sample size. So this is in hours for this time. Previously we were in minutes, but now we're looking at hours. It makes it easier for the upcoming exercises. So this one is, we can actually see this guy here. There is one in the 19 to 20 hour range and none more than that. So Donald Trump in the month of May 2020 posted every day less than 24 hours apart. Lots of tweets. And of course, in this one, we've got the most, we've got 343 tweets, less than half an hour between tweets. What did you notice? What kind of distribution might we follow? Well, we're going to be able to test some of these distributions. At the moment, I recommend Anna's Goodness of Fit tool, although really what we're looking for is going to be the exponential distribution. This is going to work better for testing distributions your students might be slightly more familiar with. So if I take this back down. Oh, I haven't done the button yet. Okay, we're going to have to bring up R for a second so that I can get the data. And then in Anna's probability tool, we're going to post those hours. We'll describe them as hours between tweets. Rounding is to the nearest 2. And then we hit update. And this is what we saw back in the randomness module. We can then compare this to different distributions. So let's say we're going to use the binomial distribution. We want to, this is going to be really hard. This isn't naturally going to fit the binomial distribution. So let's demonstrate it anyway. Let's say n is going to be 549 still. Now we need the probability of him tweeting. So how do we come up with that? Let's say there's really a probability of him tweeting. Tweeting per what? Per hour, I suppose. It'd be really difficult for students to try and come up with. So let's say each hour there's a 50% chance that he tweets, just to make things simple. We can then simulate the data. And we can see that it looks something like this. Our timelines, our x-axes, of course, change because of the way that we have changed this. And if we go build over fitted distribution, what this does is it creates a shadow effect. We can start to see a range of different things. This is a goodness of fit test. So if we hit compare to model, we can see that these two are definitely not the same. Maybe it would help if we change these a little bit. Probably help more if we just change the distribution. So let's say for lambda, we want to show the mean. Here we've got a mean of 1.268. Simulate the data. It's looking like this. It's probably not going to fit. Let's build the overfitted shape so that we can see a little bit more fuzz. Because of course we need that fuzz to be able to show how things change with randomness. And when we go compare to model, we can see this still doesn't fit. And I can tell you already, none of these are going to fit. And that is simply because these are, well, they're going to fit much better to exponential data, which, although isn't currently on the site whilst I'm recording this video, there will be an example of the exponential distribution instead. So students can explore these, come to the conclusion that none of them really work, and then have a go at watching the exponential distribution instead. So of course here, we've got negative hours between tweets. That's definitely not going to work. And we can see anyway that the shape doesn't work. Okay, so if we head back here, there we go. So which distribution fit the @real Donald Trump tweets best? As I say, I'm going to have another video in here, some kind of video, GIF, something that shows a similar effect, but with the exponential distribution. And that should fit a lot better. I'm also hoping somewhere in here to have a bit more of an explanation as to why this would be the one to go for, and especially alongside the Scampy tool, a bit more of a comparison between the Poisson and the exponential distribution and the connection we see between the two. Okay, so now we want to explore the reverse process. We're going to continue looking at the Donald Trump tweets, and then we're going to think about where most of the tweets will come from. Now, this part here is still in development. It's taking me a bit of time to make sure that the simulation or the video of the simulation is defined nicely. There should be some more things going in this bit here. So we can look at this bit here though, and see that most of the tweets are probably going to come in the half an hour section. And for our sample, we want the probability of selecting any given observation to remain constant. So we're going to do sample with replacement. The video will explain this a little bit more, demonstrate it using a clear example. But we can see some weighting data. This is a sample of 5, and we can see that we've got 1, 2, 3, 4 of the 5 observations are less than 30 minutes. They are definitely within this segment here. Yes, the video is to come. So, that was a brief example of how they might use Twitter data to explore the waiting times using a few other tools and interesting bits and pieces. So this could be quite a long multi-lesson exploration. That means that the students can explore lots of things about distributions in relation to waiting times.